Okay, so this is the 2.2 parent functions and transformations. First of all, we're going to look at we're going to look at eight different parent functions and talk about the difference between these. You should know the graphs of these eight. They're very important, and you should have seen them probably in some other courses as well. So the first one is a linear function. A linear function is y equals x. That's the equation, y equals x. So it just goes x to the first power. You don't have any exponents or anything. The domain, so a linear function looks like a line, a straight line here. The domain of a linear function, or of this one, goes from negative infinity, so all the way to the left, to positive infinity, all the way to the right. The range of a linear function this linear function goes all the way down to negative infinity and all the way up to positive infinity. Our second parent function is an absolute value function. This is y equals the absolute value of x. It is a V shape when you would graph it. You can use Desmos to graph any of these or your graphing calculator. The domain of an absolute value function also, it goes left and right forever and ever, so it is from negative infinity to positive infinity. The range of the absolute value function, the parent function, it stops at 0 and goes to infinity. So the range goes from 0 all the way up until infinity. Our next type of function is the quadratic function. And the quadratic function is a U shape. So it is y equals x squared. It is a U shape if you graph it on your calculator. The domain, this continues off to the left, and this would continue off to the right. So the domain is from negative infinity to positive infinity. The range, just like the absolute value function, it stops at 0 and would go to infinity. The square root function, this is y equals the square root of x. It is kind of a little curve out here. It starts at 0 on the domain and goes to infinity. It will continue off to the right. The range also starts at 0 and it would continue up until infinity. So those are the domain and range of the square root function. The cubic function is y equals x to the third. The domain, this would continue off to the left, and this would kind of continue off to the right. So the domain is from negative infinity to positive infinity, and the range, you can clearly see that it's pointing up and down. So the range is also negative infinity to positive infinity. The cube root function, that's y equals the cube root of x. It's different from the square root. Notice the cube root kind of looks like the square root, but it also goes the other way as well. So the domain, it's clearly pointing to the left and to the right, to negative infinity and positive infinity. The range, this is actually going down if you would continue it, and this one is actually going up if you continue it. So the range also is from negative infinity to positive infinity. And finally, the last two, a reciprocal function is 1 over x. So y equals 1 over x. If you see those, it has asymptotes. So vertical and horizontal asymptotes, that means where it kind of approaches a number, but it doesn't actually get to that number. So the domain from left to right, it goes from negative infinity to about 0, and then it kind of stops at 0 and continues on to infinity. The U shows a break in the domain, like where it stops. The range, you can see it starts at negative infinity and then goes to 0 and then kind of stops. There's a break, and then it picks back up at 0 and goes to infinity. That's a reciprocal function. This is called a greatest integer, or what's also called a step function, because it looks like steps. This is y equals this symbol, these brackets are greatest integer of x. And this function has a closed circle and an open circle. And if you look at it, it looks like steps going up here. The domain of this, it would be all real numbers, and the range also would be all real numbers from negative infinity to positive infinity, because it would continue forever and ever. The steps would go all the way down and all the way up. So that's the first page of your graph at the top, I failed to mention a parent function is the simplest function of a family of functions. So like a linear function is anything with just x. So like 2x plus 3 would be a linear function, but y equals x is the parent function, meaning it's the simplest linear function you could do. An absolute value function, you could put anything in absolute value, but y equals the absolute value of x is just the simplest, the most basic absolute value function that you could do, and that's what a parent function is. So we'll go to page 2 and talk about transformations. A transformation is how a graph has been moved or the shape has been manipulated. And we like to look at this equation. Y equals A F X minus H plus K. So all of these letters have some kind of meaning. So the A value is the number out in front of the equation. It's where y equals, it's that first number. A tells whether the graph has been vertically stretched or compressed. So if you get a big number, a number bigger than 1 out here, it's going to show that it's been vertically stretched towards the y-axis. If you get a smaller number, like a fraction, a number less than 1, it will have been vertically compressed down towards the x-axis. The h, which is inside of the parentheses, that determines whether the graph has shifted left or right. So if you add inside of parentheses, just like if you add inside of absolute value, then you will be moving to the left. If you subtract inside of the parentheses, then you would be moving to the right. So anytime you have a number inside of the parentheses, it's going to tell you whether it moved left or right. Adding means left, subtracting means right. The K value, the one at the end, so it's outside of the parentheses, it's written at the end here, that tells you how much the graph is shifted up and down. So if you add a number here, it's going to go up by that much. If you subtract a number out here, it's going to go down by that much. When you put a negative out in front of the equation, then it is a reflection across the x-axis. That means if it's up above the x-axis, it's now down below the x-axis. So it's a reflection, it's like a flip over the x-axis. If you put a negative inside of the parentheses, it's a reflection across the y-axis. So that means if it was on the left side, it's now on the right side. So it's like flipping or folding it across the y-axis. So those are all the ways a graph can be transformed or translated. It can be moved. Okay, so then we're going to look at a few examples. Example 1, 2, and 3 here talk about moving the graph to the left, right, up, down, reflect, all these different things. So let's look at example 1. So the parent function, this is a y equals something squared. So the parent function would be y equals x squared. Be the basic function, y equals x squared. And that's a quadratic if we go back and look on our first page. So it's y equals x squared. So we graph the parent function, y equals x squared, which is this one. Now this equation is y equals x minus 3 squared plus 2. So the minus 3, I'm subtracting 3 inside of the parentheses. That tells me that I'm going to move to the right by 3. And the plus 2 tells me that I'm going to move up 2. So I take the parent function and I go right 3 and up 2, and then I'm going to redraw my equation. You can look on Desmos at that equation, and it's going to match what you see there, that graph. So if you're confused about whether it moves right or left or up or down, graph it using your calculator or Desmos.com and see where it moves. Okay, let's look at example 2. This is an absolute value equation. So absolute value of x, that's the parent function, y equals the absolute value of x. In here, we see a negative in front, and we see x minus 3 in the bars. So the minus 3, again, tells us we're going to move to the right 3. So we go over 1, 2, 3. The negative in front, remember, flips it across the x-axis. So there's a reflection over the x-axis, which turns the graph upside down. And so you get that new graph. In example 3, y equals 3 to the x plus 1. So that's an exponential function. You didn't see that on our parent functions, but that's exponential. So basically, the only thing that's happened is it should be y equals 3 to the x. We have done plus 1. That plus 1's right there with the x. That would kind of be in parentheses there in the exponent. So we've added 1. So the parent equation is just y equals 3 to the x. So you draw the parent equation. And then you look at y equals 3 to the x plus 1. It's moved it to the left 1. So instead of crossing here, it's over here. Okay, it just moved left by 1 unit is what that x plus 1 has done. Okay, so let's go to the last 3 parts. It says write the equation of the function with the given transformations. So we want this to be a quadratic, so we know it's got to be x squared. We want it to reflect across the x-axis, so we put a negative out in front of it. We want it to move left 3, so we put x plus 3 squared instead of just x squared. We're going to do x plus 3 squared because we moved it left 3. And then down 2, we're going to put a minus 2 on the outside. And so that's how we have our new equation. If we want an absolute value function to reflect across the y-axis, that means we got to put a negative inside of the absolute value bars. And then we want a vertical stretch, that means we're looking for a big number, by 8. So we're going to put a number greater than 1, and we want it to stretch by 8, so we're going to put 8 there. In C, a square root function, so y equals the square root of x. We're going to move it right 7, so we're going to say x minus 7 under the square root. We're going to move it up 9, so we're going to put a plus 9 on the outside. And then this says we want a vertical compression, so that means we know we want a number less than 1. It's going to be vertically compressed by 1/2. So we put 1/2 in front of the equation. So we get y equals 1/2 the square root of x minus 7 plus 9. So those are all dealing with transformations. So when you deal with transformations, you are talking about taking a function and moving it left, right, up, down, a reflection across the x-axis, a reflection across the y-axis, a vertical stretch, or a vertical compression. Those are all the different transformations and translations that you need to know for these functions. So what you will do is after you have completed these guided notes, you'll be able to complete the next assignment on transformations and parent functions. All right, have a great day.